Cool. We're missing anyone else? Who was sitting next to someone earlier that's now going to disappear? Alright, cool. So everybody, you probably all only know me as Daurnimator, so that's what I go with in this community, I guess.
You start people. If you stop people.
People
just speak slowly.
So Fengari is a project that I've been thinking about for quite a long time. The idea is it is a Lua VM for the browser. It lets you write JavaScript. Well, let's write Lua instead of JavaScript. So it's not a transpiler. It's actually a VM, which is a support of the PUC-Rio Lua 5.3 implementation to ES6 or ECMAScript 6, which is what JavaScript is these days. It was sort of just been on my mind for a long time, and finally, I'm going to butcher his name, but Benoit, he came to me one day and was wanted to help with lua.vm.js, which is the previous project of mine, and I sort of laid out the issues with the project and why it was a dead end, and laid out some plans for Fengari. He implemented a lot of it. So why? JavaScript's not the nicest language in the world. I won't go to all the reasons why you shouldn't write JavaScript, but if you're unfamiliar with the JavaScript language, you can just Google and find thousands of things. There's a classic talk called what, or what, where it just goes through some weird like coercion rules, some oddities of the object model, etc. ES6, like ES 2015, the new ECMAScript or JavaScript standards, they all try and improve things quite a lot, and they're well welcomed, but they don't remove things from JavaScript. There's a lot of old code and detritus around, and lots of pitfalls to step in. So they just end up adding to the mess. So knowing all of JavaScript is a huge, immense task, which I think very few people ever do. Whereas knowing all of Lua and knowing the whole reference manual, at least all the quirks, is quite possible, and you can teach developers within a month, or even closer, or even within a few days to really get started. So the other thing is Lua coroutines are really powerful. They're much better than all the stuff they're going through in the JavaScript world. So they're going through callbacks and callback colors, they call it. They have promises, and now they're doing async await. Coroutines are more powerful than all of these because you can yield at arbitrary points and optionally, not compulsorily. And you can control the main loop a lot better because you won't be constantly going back through the event loop every time you want to maybe delay something. You can do it in Lua and sort of keep your CPU cache hot because every time you yield back to the main loop, that's a context switch. So whenever I end up writing code that has to work in the browser, I really end up missing Lua coroutines. So the last reason why you might want to run Lua in the browser is that the browser is everywhere. Everyone has a browser installed on their desktops and laptops on their phones. Why aren't we running Lua there? Why are we requiring to install any binaries when you maybe don't have to? So other projects did this in the past. Brazil was a really interesting one. It was a project by Tim Caswell, also known as CreationX, and it was a Lua-JIT bytecode interpreter in JavaScript. You had to compile a line, but it was a really interesting design. Lua.vm.js was a previous project of mine. You compile, it's just compiling Lua via Scripton to asm.js. It was originally by Kripken, who's the author of Scripton. I don't know if I'm all talking code to everyone. But I took over maintenance a few years ago and added better JavaScript interop between the JavaScript world and the Lua code. Another project was Moonshine, which was by Paul Cuthbert. Some of you may have seen his talk about it at the 2013 workshop in Toulouse. It was sort of interesting at the time, but he moved on to another project called Starlight, which is actually a transpiler. to JavaScript because of issues found with the Moonshine model. And then there's countless others. There's a lot of people that had their go at this. So, why another? Other projects for running Lua under JavaScript always seem to have one or two missing pieces. The two big ones are imperfect DOM inoperability, where you either can't call the DOM directly or you have to have knowledge of your ownership of DOM functions. Alternatively, they just lack coroutine support, which is, in my mind, one of the most coolest things about bringing Lua into the browser. You get to have true coroutine semantics, you can write a lot less messy code. So, Lua is quite close to JavaScript in terms of language features. The data types are all sort of there. You've got, undefined as nil. You've got booleans. You've got, objects and tables are not that different. You've got first class. You've got strings, like they index the same. They're comparable. You've got first class function enclosures. So somewhere in JavaScript, there actually is a good language. There's a lot more of it. And we also commonly use prototypical inheritance in both Lua and JavaScript. In JavaScript, it's more explicit about your prototype. In Lua, you can structure your own underscore index. But it's sort of similar. So it's a good match, I feel. So one of the biggest issues we have with lua.vm.js is that if you give an object to the JavaScript DOM or a JavaScript function, there's no finalizers. There's no way to know when JavaScript is done with your object, function, closure, whatever. It doesn't notify you. You have to either know what the lifecycle is or leak. And both of those are bad in development. So even with finalizers, if they added them, you wouldn't be safe because a garbage collector needs to see the full suite of all languages and objects available. Otherwise, you get cycles where, say, you give a closure to JavaScript and that references a JavaScript object back in Lua as an up value. If you don't have a garbage collector that can sweep all of Lua and all of JavaScript, you get number of cycles that are never collected. So that precludes things even if JavaScript did get finalizers. And for ease of use, we don't want any manual annotations or a manually maintained set of ownership semantics for passing Lua objects or closures to JavaScript. So how do we fix that? So, building Fengari, the plan was that we had to use the JavaScript garbage collector instead of bringing our own. We had to let the JavaScript GC do all the work because we could never do a sweep of the JavaScript world, especially inside the DOM. No transpilation, because transpilation, you lose coroutine semantics. There's no way to know yielding after instruction or even debug hooks, so don't work. We want the VM loop to be in JavaScript. We actually need a instruction dispatch in JavaScript itself. And so I should say that this gave us, by doing this, we've actually had the same exact semantics for debug hooks. So when you say a certain number of instructions, the debug hook should be called, we could get the exact same result as PUC-Rio Lua. And we ended up with the same code organization, meaning that we had the core written in C, we've got the low-level C API, we've got the hook slip, we've got the standard library, and they're all written in the exact same code structure. So generally, when there's a change in the Lua code, we can make the exact same change on the same line, and it usually works out. But it's very visible of what we have to change. So it's good maintainability for Fengari, so that you can always upgrade to next version of Lua the same way that in future whenever 5.4 happens. So the components of Fengari. We've got Fengari itself, which is the core. It's a port of PUC-Rio C implementation, to JavaScript, not to Lua. It's bug-for-bug compatible with Lua 5.3, meaning that all the bugs that get reported on the Lua list, I have them too. Fengari interrupt is a library interacting between Lua and JavaScript. It's written as a Lua C library with a single user data type. which means that it's sort of transparent. I'll get a bit more info later. But Fengari Web, which is all the hooks into the web browser to make everything happen as JavaScript does. So that's, for example, watching script tags. So when a script tag gets added to the DOM, we will scan that and then run it as Lua code, as long as it's got, type equals application / Lua or whatever, as well as reporting errors just like JavaScript does. So in JavaScript, when you have a top level error, it reports it to a callback called window.onError, and we do the same things with Lua error. Is the battery fine something?
I don't think so.
Then we have Fengari Node CLI, which is just the Lua command line interface, as well as Lua C, but running on Node instead of Lua. So it's really great for testing and doing things locally. We could run all the unit testing suites and standard, but just drop it compatible with Lua executable and Lua C, except it uses Node. So this was a bit of a long road to get all this. It probably took maybe 2 years of work to get this going. So I'm going to go through some of the major difficulties that we hit in trying to get Lua semantics working in JavaScript. So the first is strings. In Lua, strings are 8-bit clean. They can contain any byte, and they'll happily be in a string and live there. In JavaScript, strings are UCS2, which is UTF-16, except that we pretend that everything can have maximum 16 bits, which is not correct in either way. So you can't contain null bytes, and JavaScript strings can contain all sorts of things, like code points over 256. So there has to be a layer where we translate between sort of Lua 8-bit clean strings and JavaScript strings. Internally in Fengari, Lua strings are represented as an array of bytes, just a JavaScript array. And then we have two functions, two Lua string and two JS string, that convert between a string and an array of bytes. There are strings in Lua, like 8-bit clean, that cannot exist in JavaScript. So that is a lossy transform. Just something to keep in mind. Integers. So Lua 5.3 usually has 64-bit integers. JavaScript only has doubles, like previous versions of Lua. So what do we do? There's a really rarely used define in LuaConf when you compile Lua, where you can actually set ints to be just ints or shorts or whatever. So we emulate Lua as if it was compiled with Lua int type equals Lua int int, which gives you doubles for floats, but 32-bit integers with wraparound at 32 bits. And there is Lua code out there that will be a bit odd when this happens, but it's sort of a supported configuration for Lua itself, even if no one uses it. Tables. Lua table keys can be anything. You can have a table itself can be a key in itself. You can have any table key. In JavaScript objects, you can only have string and symbol keys. Now, symbol is a special. It's sort of like light user data in Lua, but it's a little bit different. But if you can only have tables with string or light user data keys, that wouldn't be suitable. JavaScript weak maps, which is a different data structure, they only allow objects and functions as keys. They don't allow string keys, they don't allow numeric keys. It's sort of a mess of compatibility, and you accept any object unless it's null. JavaScript weak maps are not iterable. You can't iterate a JavaScript weak map. And what do you use as a string key when I previously just mentioned that our strings are represented as arrays and equal arrays aren't equal? So in that case, we have to convert to a suitable key, and it ends up looking a lot like just the hashing that you see in Lua itself, except that we need to make it so it never collides. We just do that by sort of the equivalent of Camel and Cat with a separator, because we know that they will never collide with equal bytes. And furthermore, light user data, as we built it in Fengari, can be any JavaScript object. Even a string that, as I previously mentioned, might collide. So we have to avoid those collisions. So we have to have a layer of indirection where if you use a light user data as a key, it goes and creates a unique object to use as a key for itself. which is then uses a weak map to make sure we're consistent. Next. The next function is really complex to implement when something doesn't want it. So this completely changed the way that we had to implement tables. So given just a table and a key, you need to get the next key, where sort of is defined, there's not any order in particular, but if you start with nil, you should cover all keys and values to go with that. And in fact, the biggest thing where I had to re-architect it was when I realized that it has to work even when you give a removed or dead key. If you iterate over a table halfway, remove the key, and then ask the next, which is still the key that's now being deleted, you still have to know where to resume. And because not everything is iterated in pairs, with next you have to, you might have multiple things that's going on at the time, so you can't say cache where you were. So tables I had to implement as not just a key value map, but as a doubly linked list where each pair in a table knew what was before and after it for iteration. First, so imagine we want to remove an item from a table. First we have to hash the key and look it up in the main part of the table. And then remove it from its on the linked list. So that's looking at the previous element, putting it to the next, putting it to the previous. We delete the reference to the key value on the previous list item in the pair structure so that we don't accidentally continue referencing the previous element, which will prevent it from being collected. And then we mark the pair as dead, which is quite similar to how the Lua C implementation uses Lua T dead key to mark something as like, don't count this for garbage collection. We then delete it from the main part of the table and add the pair to a collection of dead pairs. So for every table, we have to keep a data structure of keys that were removed from that table. However, we can throw that out every time a key is added, because one of the Lua next semantics is that if you modify a table by iterating over it, or at any point, then next is no longer reliable. So if you delete something from a table, we keep the hash of the key you deleted until it doesn't exist anymore. Which actually works out pretty well. So with all that, we did get a working table implementation that gets exact Lua semantics for next, forgetting, intercept. So to iterate for next, we hash the key that you want to get the next one off. We look it up in the main part of the table. If we find it there, we have to return the pairs next field, which is simple. However, if we don't, we have to look it up in the dead pairs table, and then search through the linked list until we find a non-dead pair, which works. So, yeah, the next sort of zone is, so you need to expose Lua objects to JavaScript. And Lua objects have different semantics than JavaScript objects. So we have to massage things a bit. JavaScript does have a relatively new mechanism called proxy, which allows us to sort of bring underscore index, new index, and call to JavaScript. However, we have no way to intercept operations such as addition or subtraction or the other meta methods that you might use to Lua. Also, index and new index become, the JavaScript versions called proxy traps, are a bit different in that, what I mentioned before, that JavaScript objects can only have strings and objects as keys. They will actually convert or coerce your keys that you index with to strings or symbols before they call your proxy trap. So meaning that you can only ever give semantics where only string and symbol keys exist. So it's not that great to do a plain JavaScript object where say .foo return for Lua table.foo. Instead, we have to add methods such as .get and .set where you provide a key or a key and a value, and that goes on. And then other bits of JavaScript that do have like that. So the map type introduced in ES6 does have .get, .set. So we're not being novel, just different. Furthermore, we've got other issues. So JavaScript functions only return a single value at all times. Lua has multiple var returns, so that was a bit of a tricky one. As mentioned before, this is the intercepting operation. So if you were to add two Lua tables together using the JavaScript addition operator, what should happen? And sadly, we can't control that. So, well, you can, but you have to convert it to a string before you do it. Fengari interrupt, which is another piece of the project I mentioned earlier. It defaults exposes object with the map-like methods, which I mentioned before. However, there's a different implementation where we do the proxies, where we have the automatic string or symbol coercion, and we expose that as a function called js.createProxy. I can show that later. And when we expose an object, we create functions with methods, not objects that can be called. It's meaning that if you provide a Lua function directly to a JavaScript function that expects a callback, it will work. So you can just call callback expecting methods exactly as is. And if you do want multiple returns and you want just more than just the first return var, you can use .invoke instead if you want to get all of them or some of them or whatever. It's sort of the same signature as like Lua form. So this is a lot of code. How do we test it? We wrote our own tests against our C API or JS API. It's exactly the same as the Lua C API. So we were actually able to use the Lua test suite as well. So we fully run the Lua test suite, minus some garbage collection bits, and it passes. So we fully passed the Lua test suite. We also ported ltest.c, which is used for the Lua hard tests. And that stresses things a lot more. That's like checking what happens on C stack exhaustion. So we actually have the same behavior for JavaScript stack exhaustion as C stack exhaustion. There's a few things we had to add along the way. First one is Lua @native error, which is, so JavaScript doesn't have set jump, long jump. That's a C invention. So we had to use a try catch instead. However, JavaScript can throw native errors at various times, and we have to provide a way to filter out native errors so that you don't actually catch them. So we have this function Lua @native error, which is sort of very similar to a message handler in XP call or Lua P call, where you can provide a function that will be a JavaScript function that will be used to intercept errors that originate outside of Fengari, and your job is to convert them to a suitable Lua object. That, if JavaScript throws a JavaScript string, you might just call to Lua string on that to convert it to the array form and then return that. And the other is what I call proxies, which is probably not the best word, but it allows you to take a reference to an object on the stack and keep it in a JavaScript variable. And because the JavaScript garbage collector can still see you holding onto that, it knows when it might need to delete it. Which sort of gets rid of a lot of the use cases where you might previously use Lua lref to take a reference to an object, or other things where you need to keep a reference to a Lua object outside of Lua or in a C structure. The quick demo. So that will sleep way too fast. No? Cool? Okay. So this is Fengari.io, just our homepage, which we really need to add more information to. But for the moment, this is just a REPL. So this is running Fengari, and we can do whatever we want. So turn this off for a second. Hopefully you can all still hear me. So we can print. We can just return things, so we can have Lua 5.3 REPL.
Can you zoom in a little bit? Zoom. Can you zoom in a little bit more? Yeah, right.
We can just do all the normal things you might expect in a Lua REPL. Now additionally, we have the Fengari interrupt library available as under JS. So we can go, for example, window equals reply.js dot work. We can then do, say, window. Now I'm sure you probably all know the alert function.
Mm-hmm.
Oh, cool. And in fact, we can call any JavaScript function we feel like. Additionally, we can export things. So let's go. Well, you can all see that. It's pretty tiny. I don't think it works. Oh, it does. Excellent. Good. Good. Now, we can do a lot more than this. We can go function, window, var, x, y, return x times y. And then we can just pull it. So all know the answer is meaning of life. So we just exploited the function written in Lua to JavaScript. So how is this done? Let's have a look at the source. So standard HTML things, a style sheet, got a setup variable itself. We include Fengari Web, the web component project, which, as I said, watches the script tags. Then we have a script tag with type text equals Lua. So we can follow this, and you'll see that the whole REPL itself is written in Lua. So we're interacting directly with window, with the document. We're loading the highlight.js JavaScript library and using it directly from Lua without any annotations. So we redefine print to add to append to that div in the middle instead. And this is all written sort of in the style of the Lua C command line tool. So we do the history, so you press up and down, and press enter, it runs it, etc. So that's that. Now, additionally, we jump to this. I think that has this thing. No, that works. Oh, excellent. This is, I've just got a clone here of Fengari Node CLI. So this is the project that emulates the Lua command line tool. We can just run that. And we've got a standard Lua command line tool, except it's actually running on top of Node.js. So we can do things like, and it works. So this is a great way to write tests or to just try things out, make sure they work the same, etc. And just as a bonus thing, we actually do use the same Lua bytecode format exactly as Lua. So if you compile your Lua interpreter with that option I mentioned earlier, the Lua int type equals Lua int, you will have compatible bytecode that you can compile on the server, send to the client, and vice versa. So, and we also include the bonus with Lua C here. So we can do LLP, one that should. What did I do wrong? You remember how that works? Do you want to remember that? Oh, wait, no, you can put dash on the end. That's right. Cool. Maybe that doesn't work right now. I messed the demo up. Okay. Cool. So, the demo course. So, what are the limitations? Why isn't this perfect? And primarily limitations around garbage collection, because as I mentioned before, we have to use the JavaScript garbage collector to do all the work, all the sweeping, all the collecting. But also mentioned previously, JavaScript doesn't have finalizers. So there is no __GC. We can't do that. There's no weak tables. As also mentioned before, weak maps in JavaScript. are not iterable. So we can't implement any Lua semantics that people care about. So we just ignore underscore mode. And collect garbage and Lua GC are mostly unimplementable. I've got some code around, for example, count, collect garbage count, we can do because Chrome supports getting the amount of memory in use by JavaScript, but Firefox doesn't. So that's a bit dodgy and they're not standardized. And some functions are only available under Node. So the IO library doesn't make any sense in the browser, there's no files. So, but under Node, it does make sense. We actually can write a file system. In Node, Fengari Node CLI, you can open a file and do whatever. Which importantly makes sure that IO.standard error : write works for debugging. I suppose I should use this. Otherwise, OS.remove, rename, OS.temp name, and OS.execute. None of those work in the browser either because it doesn't make sense to deal with files. However, in Node, it'll work. Notably, the IO Node doesn't actually garbage collect file handles. If you forget to close or throw an error in Node, you link the file handle. So the IO is a bit limited in that we also can't implement that. So be very careful with IO. In fact, just be careful if you write JavaScript in Node because you will link file handles. It's amazing how many libraries out there will accidentally throw and just link a file handle. So the biggest question I usually get is then, well, how's performance? And well, we haven't optimized it yet. I've been mainly focused on getting all the semantics correct and making sure that it behaves the same and passes the Lua test suite. But preliminary benchmarks is about 20th of the speed of native Lua, which I think is pretty usable. You can pull it open and, as long as you're not doing huge computations, it's still faster than humans perceive and care about responsiveness. And you always have the option, just as you do in normal Lua, you can write a hot loop in C, or you can write that in JavaScript or even WebAssembly, because then you can optimize it for a lot more FAQs. So people ask me, so why don't you use WebAssembly to write this? And the answer is that WebAssembly doesn't directly allow interacting with the DOM, and the JavaScript garbage collector doesn't sweep WebAssembly structures, which means that all the things that we went before through with interop are impossible with WebAssembly. I think that it's going to be a major issue with WebAssembly users moving forward. Hopefully they fix that, but I don't have high hopes. And I really want underscore GC. Well, that's not a question. The closest path is a proposal from TC39, which is the JavaScript steering committee, to add finalizers. So if you really want underscore GC in your Lua in your browser, then you'll have to convince them, and there are proposals and forms for that. So if you're keen, please do follow that. Questions?
What's the driving factor of your motivation behind this project?
So the question was, what is the motivation behind this project? And the answer is that I keep seeing people implement Lua VMs in JavaScript and doing it wrong. So I had all these plans of how it should be done correctly, and every time someone would ask a question on the mailing list of IRC, and I would answer them and say, this way you can't do it this way, this way you can't do it this way, they would then go do it the way I told them not to, and they would then fail the project. So, there's a lot of implementations out there, and they all have issues, and I've tried to create one without those issues. I also should give massive props to Benoit because, probably butchering his name, because he did get this project off the ground. It was all in my head for a couple of years, and then he was asking me and he wanted to help, and so then he wrote probably the first 50% of this before I came in and sort of started working on a lot more. So. Oh.
What?
You both did exactly the same time, so.
What options did you consider for integers before deciding to use 32 integers?
So none of the current browsers have 64-bit integers. If you write an extension for Firefox, you can access them in a very similar way to Lua.js has 64-bit integers and C data. They don't quite work as table keys, they don't work for things expect integers, but you can sort of do them. And maybe if that was more well supported, I would consider that more. But the alternative was using sort of 53-bit integers, because that's what you can fit in a double. But JavaScript bit operators all work on 32 bits. Like they have gone to bit 32, everything gets wrapped around at 32 bits, so it was just natural to use them. So.
My question is that you said that you had to represent Lua strings as
arrays of bytes.
So how did it work when you assigned to the window object a string and it showed up as a string?
So the window object there is a user data of type JS, which has an __ new index, where it detects the type of the key or and the value, and it converts the key from an array of bytes to a JavaScript string, and then adds it to the window object, and then returns. Yes?
Does the word Fengari have an origin or a meaning?
So Fengari was come up by Daurnimator. It means wolf in Greek, which apparently meant what to him. As I said, he got it from an idea to the start actually writing code. So he made those decisions. Yeah.
When would you use the C API over the FFI?
So why would I use the C API over the FFI?
Yeah.
Well, in PUC-Rio Lua, the FFI is written on top of the C API. So you would need both if you want the FFI or skip a layer and don't have the FFI.
But it seems like the FFI covers all use cases.
So in this case, so the FFI here to talk with JavaScript is the project Fengari interop, which is written using the C API. So the FFI is implemented using the C API. Joel, is that questions?
So why not put Lua natively in the browser?
How would you
Is
use
it forever cursed to use JavaScript?
Yes, so whenever you talk to a browser author about putting another language in the browser, first they tell you we've done it before and no one cared, which was back in 97, 98. And secondly, that you should use WebAssembly. When, I don't know, get into a big argument about how you can't interact with the DOM and the gut, which like you can't see things, and then they disappear and never listen to me again. So, yeah.
Do you have a feeling for where the performance bottlenecks are in the current implementation?
So, I think there's a few performance bottlenecks in the VM, so Lua execute function, which is the core of the VM. In Lua 5.4, there actually are some improvements where there's new bytecode things for integers specifically and floats specifically. I think that branch between, say, any add operator between floats and integers is probably a relatively large bottleneck for mathematical computations. Other than that, there's no real hotspots that I've sort of guessed at. If someone was really enthusiastic, they could probably write a Lua.js 1.0 analog for this, where you could take the bytecode and emit JavaScript or WebAssembly, but manipulate JavaScript objects to do it. So there are paths forward, but I think I've just been concentrating on getting all the semantics correct, so it's just so people want to use it, because there's no point in playing fast no one wants to use. So yeah, I do welcome anyone to give it a try. Next time they want to write a small front end or like a demo, just give it a go. Like, write a Lua instead of JavaScript. You can use any JavaScript library that may already exist. So.
Cool.
Yes.